يا شباب إن شاء الله we will continue our discussions on speed control of induction motor. The topics today is to cover the bullet changing control. We didn't cover it last class. We said we will start it in this class by bullet changing, and we will answer the questions. The question of your colleague: what are the limitations of variable frequency or variable voltage variable frequency control? Then we will solve some problems regarding speed control by using frequency and V over F control. So starting from bullet changing يا شباب. Last class, unfortunately, there was a mistake in the slides, so I corrected the mistake here. The curve was for another case يا شباب, was for pole and the frequency changing together. So and it was not correct. For that, I said we can start or check it and start it in the next class. For that, I corrected here the case. So please upload the modified version of the slides from Blackboard. Okay. So as you can see, Shabab, here, if we consider the maximum torque, S maximum and N, what is the relation with number of poles? If we can see here in T maximum, we have omega S in the denominator. So we have number of poles here in the denominator. So if the number of poles is increased, the torque maximum will be decreased. As we can see here, when the number of poles was 6, here number of poles was 6 poles. When we increase to 12 poles, the maximum torque is decreased. Also, for the synchronous speed, you know NS equals 120 F over number of poles. So if we increase the number of poles, it's expected to have lower synchronous speed. طبعا يا شباب, take care about the difference between synchronous speed and motor speed. It's totally different. Synchronous speed means NS, which is the curve boundary. However, motor speed means the intersection between the motor characteristic and the machine characteristic. So we can say that we can make speed control by adding poles. However, is it going to be increased or decreased? We have to check first the intersection between the between the characteristic of the machine and the load characteristic. يعني here, as you can see, for instance, if we have a load torque like that, constant load torque, assume that we have constant load torque like that. So the operating speed for the first curve of the 6 poles is considered as that speed here. However, for 12 poles, this is the operating speed now. Tamam? Is it similar to synchronous speed or different? Is the value of N similar? It's different صح؟ طبعا little bit different صح? This is because the characteristic is almost linear here in this part. Okay? طيب. So if we increase the number of poles, as you can see, you will find that the motor speed and synchronous speed both are decreasing. طيب. And maximum torque as well. What about S maximum, شباب? S maximum is proportional to R over X equivalent. صح؟ صح يا شباب؟
Yes.
So, is there any relation between S maximum and X equivalent and number of poles?
No.
There is no relation. مظبوط يا شباب؟ For that يا شباب, here you will find S maximum is constant. However, someone can say here S maximum is here at that point. صح يا شباب؟ However, it's changed here. Is this right or wrong?
The relative position.
It's relative, exactly. طيب, can anybody else declare يا شباب why it's different in numbers? Please, Nawaf, can you please describe, Nawaf, what is the reason here? Although the value of S maximum should be constant, it's different on the plot here. Can you give me example in numbers? Nawaf? Is Nawaf here? Turkey?
نواف مين يا دكتور؟ في اثنين.
We have only
Yes,
one Nawaf.
doctor.
صح؟ Nawaf السعيدي.
Yes.
Please, Nawaf, can you please يعني, describe here why the position or the point of S maximum has been changed, although the value of S maximum is constant? Can you describe this? In numbers, to be easier for you, let's say in numbers. If S maximum is 0.2, what is the value of S maximum in this curve and on that curve? Sorry. Let me discuss it again, Shabab. Again, now if I said S maximum is 0.2, is it possible to say S maximum here is 0.2 and S maximum as well here is 0.2? Is it right or wrong?
I think it's right.
It's right, exactly. Like Hisham said, Shabab. Why? Because we said before S maximum or S here in general is considered as a per unit value of the synchronous speed. So this point is 0.2 of the overall NS. And this is also 0.2 of the overall NS for that curve. So although the value of S maximum is constant, it's appearing here that it's shifted. Why? Because the reference has been changed. Tamam? Why the reference here has been changed? Because you know NS is proportional to 1 over number of poles. صح يا شباب؟ طيب. يعني it's very important شباب to recognize the differences and what will happen to the curve boundaries if we make any speed control technique. تفضل if you have a question.
Doctor, I didn't get this point. Why we get exactly the same?
Let me draw another curve here in order to be more clear. Let's draw in numbers. Here you have a curve like that. This is a scale of S maximum for a certain motor. Assume that this is a natural characteristic of that motor. Okay. أو خليني معلش let me correct the characteristic. Raise again. This is characteristic number 1. S maximum here should be the value which is corresponding to T maximum, which is here. Type. Here, assume that you have NS equals 1800. If S maximum is 0.2, what is the speed at the value of S maximum here? What is the value of speed in this point? We can say NR equals 1 minus S multiplied by NS. صح يا شباب? Is it right?
Yes.
Right. So we can say it's 0.8 multiplied by NS. Right. If we make now a change in the characteristic, assume we are going to make pulley changing. Pulley changing, instead of having number of poles equal 4, which is corresponding to NS equals 1800, if we change it to number of poles equals 8, so the NS now will be 900 only. صح ولا غلط؟ مظبوط كده؟ So if we change the characteristic يا شباب by changing the number of poles, now NS will be 900 only. So the new characteristic will be like that. And this is also representing S maximum. S maximum for curve number 2. This is S maximum for curve number 1. And if we said that S maximum is constant if we make bullet changing, which means S maximum is still 0.2. So what is the speed NR2 at S maximum 2? It will be 1 minus 0.2 صح كده multiplied by NS which is 900 here تمام. previous one was 0.8 multiplied by 1800. Here it's 0.8 multiplied by 900. So the value of S is not يعني ايه reflecting the right position of speed. Why? Because it's in per unit of NS يا شباب. يعني S maximum here equals 0.2 and S maximum here is also 0.2. But because NS is different, the position of S is different on the slip characteristic or speed characteristic. Is it clear now? ها؟ اللي كان بيسأل يا شباب. Is the question clear?
Sorry, doctor, but I didn't get it.
You didn't understand yet?
Yes.
طيب احنا قلنا يعني now by changing number of poles S maximum is constant صح ولا غلط؟ So if S maximum is constant here which is 0.2, the question is the value of S maximum will be constant on the x, on the horizontal x or not? This is the question. And we said not, it's not equal for both of cases. Why? Because it's relative to the value of NS. NS has been changed from NS1 1800 to NS2 which is 900 here. تمام? So you cannot say 0.2 per unit is the same point. يعني let me say يعني give you يعني another example. If we say for instance you have for instance 1000 riyals and we said your son has 10% of what you have. So your son will have 100 riyals صح? Is it right? تمام? Another colleague to you has 2000 riyals and his son has also 10% of his money. So the son here will have 200 riyals. Is it right? اللي بيسأل يا شباب خليك معايا. المثال واضح ولا لا؟
Yes, yes, yes.
So يعني both of sons have 10%. However, the actual value is different. Is it clear? Here is the same. S maximum is the reference. So, sorry, NS is the reference. So we cannot say S maximum, which is here 20%. We cannot say it's the same value in terms of speed. However, in per unit, it seems that it's same. It's similar in per unit. However, in actual value, it's different. Why? Because the reference has been changed. Okay, this is the reason. Yani we have S maximum of 0.2, which means it's 20% of NS. This is the meaning of S maximum per unit or SM per unit. تمام؟
تمام.
Okay. طيب. So regarding the advantages and the drawbacks of pole changing يا شباب, for increasing pole changing firstly will lead to synchronous speed decrease. Starting torque decrease, as you can see by increasing number of poles. Starting torque also decreased. Maximum torque decrease. So this is now considered as a drawback. Why? Because if you have constant load torque, you will find that the maximum torque may be less than the value of constant load torque. And this is called stalling of the machine. Stalling. Stalling means the machine characteristic has been changed and the torque became higher than maximum torque. So the motor cannot drive the load anymore. So the drawbacks here, شباب, or the drawback, it's only one. Only valid for steps. Yani you cannot make wide range of speed control, and also it's not suitable for starting with constant load torque, because at starting the starting torque will be decreased, and also you have to check the maximum torque value in order to avoid any problem of load stalling. Right. This is regarding the pole changing And to be honest with you, it's not used a lot in our life today. We discussed last class also the frequency control, and we could see that by increasing the frequency, you can find here, this is the direction of frequency increase, and you'll find that maximum torque is decreasing, starting torque is decreasing, NS is increasing. So this is the curve directions if we increase the frequency. Type drawbacks and advantages, as we discussed in terms of flux, we said that flux is proportional to E over F, which is voltage over frequency. Okay, so if you have low value of frequency, the flux may be saturated and makes problem with the machine. Also, if the frequency is very high, the flux will become small, and this is going to make the machine working in the weakening mode or overspeed mode. طبعا weakening mode, it means you may have a problem in the bearings of the machine due to high speed. However, if you design your machine to work in the field weakening region, there will be no problem. طيب.
Sorry, Doctor. Actually, I didn't catch the meaning of weakening.
Weakening, it means the flux became small, and if the flux became small, this means the load will not be catched in the same way, will not be put in the same way, which means the speed will be increased. Assume that you have like wires and you catch the load by these wires. If this wire became weak, this means the load will be over speed, because the flux lines now became weak. Okay, is it clear? If the flux became weak, the speed will be increased. Is it right or not?
No, not clear.
You cannot imagine. Type. Assume that you have a load or object like that, and this object is trying to move in this direction by a certain speed v. And you already make here like wires, okay? And these wires are fixed here in a certain object, okay? If you have high speed here, you will find that this wire will try to reduce the speed of the object. صح ولا غلط? This is the aim of this wire. مظبوط?
Yes.
So this wire here try to prevent this object from moving. Now, if this wire became weak, what will happen to the object?
Run away.
It will run away. This is the same as flux and the motor speed. Flux is catching the rotor. If the flux became weak, the rotor will be over speed. Okay, this is physically what happened if you reduce the flux in the machine. So this is why we have a problem with field weakening. طيب, is the speed increase considered as a problem? Sometimes we need to increase speed. This is regularly for speed control. However, if the speed of the machine increased over the bearing rated speed, this may damage the machine bearing. For any machine يا شباب, we have bearing rated speed. For instance, if the machine is, for instance, 1800 RPM, you may find the bearing speed or bearing rated as, for instance, 2000 or more than 2000, maybe reach to twice of this value, 360 or 3600 RPM. Now, if you increase the speed of the machine to be greater than 3600, which is the rated value of the bearing, what will happen to the bearing itself? It will be overloaded and it will be damaged. Tamam? So if you would like to operate the machine at overspeed, you have to consider this in the design of the bearing. Otherwise, the motor bearing will be damaged. So this is the limitation of frequency. For that, we prefer to keep flux constant. we need to make speed control by any way. However, we could find that we have now a problem with flux. So in order to keep flux constant and keep controlling speed, instead of changing E only, which is V, or F only, we can change both together, but with the same ratio to keep flux constant in order to avoid any flux weakening or flux saturation. So this is the better technique compared to the frequency control. So it's better to use constant flux control. So we keep V over F constant all of time. If we would like to keep V over F constant, what will happen to the machine characteristic? What will happen to the parameters? We discussed this last class. Also, in terms of maximum torque, you will find that maximum torque from the relation here. This is the relation of maximum torque. It's proportional to V squared over F squared, because you have here F and you have in X also F. So it's V squared over F squared. So if you change V over F or make V over F control and keeping V over F constant, T maximum will be constant. S maximum will be a function of F only. It's not a function of V. So it will be changed. NS, it's function of F only, not V. So it will be changed as well. So if we apply this to the machine characteristics, you will find that T maximum is constant. So T maximum is constant, as you can see. NS is variable and depend on the frequency only. So by increasing frequency from F3 to F2 to F1, NS will be increased. Also, T starting will be increased. We will see that in our problems. T starting, you know, you can apply in the equation of torque at S equal 1 and get the value of A of T starting by approximation. We will see how we can make it in problems, inshallah. I starting is constant. We will see also the effect of V over F control on starting current. And from the advantages, Shabab, it's wide range of speed control, which means you can move the characteristic whatever you need. And this means that you can vary the speed at wide range. So this is one of the advantages of the V over F control. We discussed also, Shabab, how we can make V over F control practically, and we said V over F control can be made by variable speed drives, VSD. We will discuss it, inshallah, at the last topic in our course. And this is here the characteristic for V over F up till rated speed here, Shabab, or rated conditions at 1 per unit, So we can consider the control at this region as constant torque because, as you can see, torque maximum is constant here. Constant torque, constant field control. So at this part, we have T maximum constant, which is due to V over F is constant. Type. Now, if you would like to increase the speed over the rated value of voltage and frequency, can you increase the voltage over rated? And you have motor of 400 volt. For how much you can increase the voltage? For any kind of AC machines, for how much we can increase the voltage over the rated value?
Maybe 5%.
You know,
10%.
Yes, 5 to 10% may be acceptable. But over than this value, it will be a big problem because it's affecting the insulations of the winding. So we do not prefer to operate the machine at a voltage higher than rated one. So how we can continue making the speed control after V rated? Just by changing only frequency. So at the first part here, we apply constant flux. At the second part of control, we apply frequency control only. And if we make frequency control only, this is going to make flux weakening, Shabab. Flux weakening. So this is considered as the weakening region. Weakening region, which means overspeed region, which we have here at speed higher than the rated speed of the machine. So this is the limits now of the variable voltage, variable frequency control. Limiting of this technique is the rated value of volt. Okay, So we shouldn't go beyond the rated voltage of the machine. طيب. Is the question clear now, Sham? Am I answered your question now? Right,
Yes,
okay.
now it's clear. Thank you.
Okay. This is a block diagram for the variable speed drive. As you can see, we have many shapes for variable speed drive. This is, I believe, for Siemens company. Okay, this looks like ABB1. Okay, so we have many companies who are producing variable speed drives. Type internally, what is inside variable speed drives? It's nothing but rectifier inverter, which we call it as back-to-back converters. Rectifier, it can be controlled or uncontrolled. Here, this shape is for uncontrolled. Uncontrolled, it means the output voltage will be constant, will not be controlled. The output voltage here, all of time after this capacitor, will be square root of 3, square root of 2, multiplied by the RMS. This is the output of this A volt. If we have here 3 or phase V phase equals V RMS, so you will have V DC equals square root of 3, square root of 2 multiplied by V RMS, which is the peak value of line. Peak value of line volt. It's uncontrolled. After that, we will apply certain control technique by delivering pulses to the gates of these 6 switches. And these gate pulses are coming from a digital controller, like Arduino, for instance. All of you know the Arduino microcontroller, and we have many types of digital controllers that can be used. Okay, so it will deliver the pulses that will control the operation of these circuits, these switches, which is called inverter. And this shape is called voltage source inverter because we have many types of inverters. This is called voltage source inverter. The output of this inverter should, the output of this inverter is AC and includes some harmonics. It's not pure sinusoidal. Okay, we call it as quasi-square waveform. So the output here will be quasi-square, which is corresponding to the required RMS voltage needed for the motor. We can control here, Shabab, we can control both V and F, or V only or F only. So you can control whatever you need by using this drive. So this technique, Shabab, or this drive system can be used to make voltage control only, or frequency control only, or both V over F control. It's not only for speed control, Shabab. It can also make smooth starting for the machine. It's not only starting and speed control, it can also make something else called braking. And this will be discussed, inshallah, in the next class. So the variable speed drive can make all of modes of operation for AC machines. Now we discussed the speed control. We will discuss briefly starting and in details the braking of induction motor. So this drive can make all of control modes of the machine, either starting, speed control, or braking. Because, Shabab, it's logic. In order to make the 3 functions, starting, speed control, and braking, it's not logic to bring 3 different devices. However, if you have one device that can control the machine in the 3 modes, it will be better. And this can be achieved already here by variable speed drive. Okay. Let's solve some problems.
Actually, in this case, usually in the drive itself, we don't have the capacitor to just overcome the harmonics. Am I right?
We don't have capacitors?
Yes, because as you said, Doctor, the output AC, it will carry some harmonics because of the switches.
Yes.
So
because of the operation, this is the normal operation for voltage source inverters. You will have some harmonics.
So at
what
the
is
end,
the
should
relation
we
now with the capacitor? What is the relation with the capacitor? Capacitor here is considered as the source. It's used to smooth the output of the rectifier, to have a constant voltage here. This is the function of capacitor. And you have to use capacitor.
No, I mean at the end, should we install capacitor as a filters?
Ah, okay. You ask about filters now. Type, because a filter is not only capacitor. We have many shapes of filters يا شباب. I will share with you. I made one chapter regarding filters and harmonics in another university in one of the books I made before. I will share it with you شباب just for you to understand the meaning of harmonics in AC systems and how we can reduce the harmonics using filters and with different types of filters. We have something called passive filters. We have something called active filters. Okay, we have filters for certain order of harmonic or band of harmonics. Okay, so the filters have too many shapes. It's not only capacitor, it can be LC with R. Okay, and the idea of filter is nothing but resonance. It's applying resonance at the frequency of the certain harmonic you need to remove. ماشي? So you can add a filter here according to the load. However, for induction motors, it's not important. Why? Because the motor itself includes L, and this L can reduce the harmonics in currents. We will discuss this, inshallah, in more details in the last chapter. ماشي? However, if you have a certain load which is sensitive to harmonics, you have to add filter. So adding filter or not, depending on what's the application that you are going to supply. ماشي? If it is AC drives, so it's not important. Why? Because the inductance of the motor itself will act as a filter. ماشي?
So, Doctor, we don't need to use filters always. Depends on the
Not
load.
always. It depends on the load.
Okay.
If the load is critical and needs pure sinusoidal supply, you have to add filter. Otherwise, you will have a lot of problems. But for induction motors or AC motors in general, we need to reduce only harmonics, not to have a pure sine wave. Okay? And we can reduce the harmonics, by the way, by the control technique. So control technique itself can reduce the harmonics, like pulse width modulation with many types. We will discuss it, inshallah, as we discussed in the last chapter. However, besides the PWM control, the waveform here will not be sinusoidal. It will include also few harmonics. In order to remove all harmonics, you have to add filter. But this is if you have a critical load that it's not allowed to use or to supply by any harmonics. But for in case of machines, in case of motors, you don't need to add this filter. Why? Because the machine itself will act as a filter. Because you will filter the current. So the current will appear like sinusoidal current without any or with very few harmonics, ماشي? Which will not affect the motor performance anymore. Right.
Sorry, Doctor, that's a question actually. As you said, regarding the signal reduced by the Arduino program, is there any other program we can use to just control that signals?
You mean not program, but you mean digital controller?
Sorry, digital controller. Yes.
Yes, we have many digital controller. Whatever the controller you are going to use, lots of controllers you can use. You have any kind of microcontrollers, any kind of microcomputers. You can use FPGA, you can use DSP, you can use DSpace. Many digital controllers can be used. Okay, the idea is simply you have to make programming within this digital controller in order to deliver some pulses here to these switches. What is exactly the digital controller you can use? It's up to you. We have many types of controllers, and you can select whatever digital controller suitable for your code, up to the length of the code, up to the speed you need in order to supply these pulses. Ma'am?
Can we use PLC in that?
Can we use what?
PLC program as a digital controller?
PLC can be used as a digital controller. However, if you would like to make like PWM techniques or like that, it's not easy to be used with the PLC itself. However, you can make another controller with PLC to include a processor. Okay, يعني along with PLC, you can equip a processor with the PLC itself in order to make this control. However, PLC itself, it's not used for that high frequency control because you need here high switching frequency. يعني, by the way, we prefer the switching frequency شباب for this kind of converters to be higher than 20 kilohertz because less than 20 kilohertz will make noise because our ear can recognize any noise less than 20K. If it is higher than 20K, we cannot recognize. So we prefer in our electrical drives applications to increase the switching frequency over 20K. Tamam? So for that kind of high frequency, PLCs will not be suitable itself. However, you can equip it with another processor that PLC can control as well. But the code of pulse width modulation will not be written on the processor of the PLC itself. It needs external device. ماشي? For that, يعني microcontroller is preferred. This is one. Number two, if you equip PLC with a drive in order to operate the machine, it will be very expensive. PLC devices are not cheap. However, you can bring microcontroller and make all of this code in a very cheap price. يعني just $1. You can bring microcontroller of $1 and control the drive. What do you think about the PLC cost? It's very expensive. صح ولا غلط? So we can use PLC controller as supervisory control, not the basic digital controller. يعني PLC may control a lot of variable speed drives as a master control, not as a unit control. Okay. Let's start, شباب, in solving some examples here. We have 480 volt 2-pole 60 hertz star connected induction motor has an inductive reactance, which is X equivalent equals 4 ohm, stator resistance 0.2, rotor resistance referred to stator 0.3. So you have R2, you have X, you have R1. The motor is driving a constant torque load of 60 Newton meters at a speed of 3500 RPM. So what is this speed now, شباب? What is this speed? Faisal, please.
This is the rotor speed.
This is the rotor speed. At which operating condition? This is Faisal speaking? Faisal Khattabi.
Yes, doctor.
Please, Faisal. Now we read here a speed of 3500. What is exactly this speed?
The rated speed.
Rated speed, bravo, ممتاز. So this is now the full load or rated speed يا شباب of our motor. At which conditions? At the condition of supplying the machine by 60 hertz and rated voltage. Okay? طيب. Assume that this torque includes the rotational component, which means the torque here itself includes the rotational component. يعني how we can consider this in solving the problem يا شباب? Just by neglecting the rotational loss. يعني this expression here means you can neglect rotational loss because it's already included in our torque here. طيب, what's required here يا شباب? Compute the maximum frequency of the supply voltage that would not result in stalling the motor. يعني ايه يا شباب? What is the meaning of this expression? Now, let's discuss the characteristic together. And we said before that assume this is the natural characteristic of the machine. This is torque, this is speed. This is the maximum torque, and you have here a constant load torque of 60 Newton meter. Assume that this is the constant load torque 60 Newton meter. The question now, it's required to make speed control by using frequency, and we don't need the machine to be stalled. So we need to calculate the frequency that can be used in order to control the machine, or the maximum frequency without stalling the machine. طبعا maximum frequency, it means we are going to increase the switching, we are going to increase the frequency شباب. And you know increasing the frequency is in this direction, because you know n is a function of frequency, and n increased in this direction, so frequency also will be increased in this direction. So it means that if you increase the frequency, it may be like that, and so on like that. Right. The question is, what is the maximum frequency that can be increased without stalling the machine? Stalling the machine, it means the maximum torque equals the load torque. This means that this is now the critical characteristic that we are looking for. Is it clear? The meaning is the meaning is of question. Is it clear now? في أي مشكلة?
Yes.
Anybody has any problem in the meaning of the question?
Sorry, doctor, the stalling of the motor, is it based on the starting torque?
No, now we are speaking about the speed control. Starting is already passed. Now the machine is working and we need to make speed control.
Okay.
So we don't care about starting now. This is a speed control problem. Type. So Shabab, now we need to calculate what is the frequency that will make stalling for the machine. Why we need to calculate this frequency? In order to avoid increasing the frequency over this value, to keep this load working safely. Type. How we can do that? Simply, we will operate and find the value of frequency at T maximum equals the volume of the torque equals 60. So simply, you know that the maximum torque equation, this is the maximum torque equation, and by neglecting the values of R1 compared to X equivalent, because R1 is smaller than X equivalent, so we can make small approximation here, which is T maximum equals 3V square over 2 omega S X equivalent. So we can use this approximate solution يا شباب. دايما all of time in speed control try to use approximated solutions to be easily to can calculate easily the required data. Type. If we have the relation now of T, we said that T maximum equals 3V phase square over 2 omega S X equivalent. This is the relation. But you know, omega S is a function of frequency, and X equivalent also is a function of frequency. So in order to get the frequency we need, we have first to consider the frequency of these speeds and reactance. You have the reactance at 60 Hz, and you have omega S at 60 Hz as well. So in order to get the value of critical frequency, you should divide the value of omega by the 60 Hz. And the same is also for X equivalent. So we can say now T maximum equals V squared, which is V line now, شباب. طبعا we discussed it before. V line squared equals 3V phase squared, because it's Y connection. And this is the required frequency over 60, okay? Because as we said, omega S and X equivalent are a function of frequency, are functions of frequency. So now we can substitute in the relation. You will find you have only one unknown, which is F. After calculating F, شباب, we can find here the maximum frequency or critical frequency that will stall the machine is 67.7 Hz. So in order to control this machine, you shouldn't increase the frequency to that limit. Why? To avoid stalling the machine. Type. The question now, if the value of load torque is changed to another value, is the frequency will be changed or not, شباب?
Sorry, doctor.
Again, the question again. Now we calculated this frequency according to our loading condition, which is 60 Newton meters. If now the load again, if now the load became 50 Newton meters, if the frequency will be the same, if the critical frequency will be the same, or it will be different.
It will differ.
So for now, شباب, in order to define the critical frequency, we have to consider the loading. It's not general for motor. It's not constant value for motor. It's now considered as load dependent. صح ولا غلط؟ يعني according to our load now, the value of F critical will be changed. This is very important. تمام؟ طيب. So this is now the critical frequency, what we need. The question number B, calculate the motor current at 60 Hertz and at the maximum frequency. So now we have two operating conditions, شباب. One at the maximum frequency and one at 60 Hertz. We need in this, in number B, to calculate the motor current. The same in number C, we need to calculate the power delivered at both of frequencies. تمام? Let's calculate the current. طبعا in order to calculate the current, we need to get V over Z at the operating condition. In the first case at 60 Hertz, you have to consider the slab. What is the slab? Simply slab at full load, we can say NS minus N over NS. We have N, which is 3500 given, and 3600 is the speed of synchronous. So we can get the value of slab and substitute here in the equation to get the current. So the current here now, شباب, the current at the steady state is 23 amperes. This is at 60 Hertz. طبعا in order to calculate at the maximum frequency, so you should change the value of X in terms of the second frequency we get. So we can calculate the current by the same way at the maximum frequency, which is occurred at maximum torque. So we need to calculate first the maximum slip to get the speed. So to get the value of S in our equation. So we can say S maximum equals R2 prime over R1 squared plus X equivalent squared, and X has to be considered with the new frequency. So we can calculate X equivalent at the new frequency. After that, substitute here in the equation of current to get the value of current at steady state. Can you see? By increasing the frequency, the value of current is increased at steady state. So you operate now at maximum possible torque according to the characteristic, and at the same time the current has been increased. Regarding the speed, شباب, if you would like to calculate the motor speed in this case, in the second case, after increasing the frequency, طبعا substitute here in the equation N equals 1 minus S, which we have already obtained, multiplied by NS, and you know NS at this case is 120 multiplied by the value of new frequency over number of poles. So the speed now is 3792. It's greater than the speed of the rated at the rated frequency. طبعا this is expected because as we could see here in the characteristic, this is the new characteristic and the speed should be increased at this portion. Right. Then we need to calculate the delivered power to the load, which is the output power. طبعا simply output power can be calculated as T multiplied by omega. طبعا here يا شباب يعني we neglected the rotational loss, so we can say now P out equals P mechanical, which is torque developed multiplied by omega of rotor. So simply we can say now torque, which is constant 60 Newton meters, multiplied by 2 pi over 60 multiplied by the speed of rotor. This is 3500, which is at 60 Hertz. So this is the power at 60 Hertz, and here is the power at the other frequency. So this is our speed now, 3792. This is the speed at the maximum frequency, and as you can see, this is the output power at maximum frequency. So the maximum power or the power delivered to the load at the higher frequency will be increased compared to the output power at the 60 Hertz. Okay, this is due to an increase of around 8% in frequency shift. The example next, we will compute the same, but if we decrease the frequency to 50 Hertz. يعني I need all of you to read this example, okay, and compare the results with example number 3, and we can discuss it inshallah in the next class. Any questions, شباب?
Sorry, doctor. This is in the case of the constant load or constant torque.
Yes.
But if we have different, all the calculation will, I think.
If you have
change.
different load characteristic, so you should apply the characteristics or the table what we have used previously. We used a table here, this table. According to the load type, you should select your relation. Now, we are working with the constant load torque. However, if the load torque is changed, you have to consider the characteristic of load with the characteristic of the machine. Okay? Yani we will see, inshallah, also for in the next examples how we can use other loads. Any question, Shabab?
Thank you, Doctor.
Okay. You are welcome. طيب يعطيكم العافية شباب. نراكم الكلاس القادم على خير إن شاء الله. السلام عليكم.